What do we have here? Another rescue radio. Now, I have done a setup on one of these before on the channel a little while back in 2021, I think it was. The realistic TRC-1004. These were a rescue radio that was very popular alongside the Cybernet ZX1 and others back in those days when mobile phones weren't an option. And this one has come in from another viewer called Steve. This is Steve G, let's just say for the sake of argument. And he sent me this in because I don't think it's working right, and he said that I can either repair it and send it back to him or keep it as spares. Now, I'm a thoroughly honest individual and thought we would take this apart and really try and get this working for him. I'm not sure what it's doing, what it's not doing. That's what we're about to find out. He's also supplied the looks like the original adapter lead, cigarette adapter lead. So I'll just check that out and make sure that's all right, and then we'll get it hooked up and see what it's doing. Right. So whenever I get a rescue radio, I always use an adapter and check the customer's supplied adapter here, because we're not getting any voltage out of this. I've just tested it, so we need to unscrew the cap here and just check to see if we've got a fuse in there, and if we have, that the fuse is okay. It's not blown, but it does appear someone's repaired the fuse with a little bit of copper wire. You see that? Not seen that before. They've run a bit of fuse, just a normal bit of thin stranded wire through the fuse. Alright, so we'll take that out and we'll put a proper fuse in. 3 amp is all it needs. Right, we appear to be on frequency. We're doing just under 3 watts there on transmit, and then on low power we put it on the low scale. We're doing 0.4 of a watt on low power, so that's okay. So 3 watts on high power, and we definitely are on frequency. And we do appear to have modulation as well, so we'll just put that through the deviation meter. Right, I think, and this is where we've got our problem. We're not getting any audio at all. So it's transmitting, it's on frequency. We're feeding a signal into it now. I'll just put the signal up to 100 microvolts so we give it a fighting chance. So we've got 100 microvolt signal going in, and we've not got anything coming out of the speaker. Okay, with the back removed, I think we can see we've had a problem over time here with this. Now looking at this, it's had water ingress. There's absolutely no doubt about that when you look at this. It's either been dropped in a puddle or some kind. Okay, we can see more corrosion around the top edge of the switch there. You can see that, and then we've got a bit around the pot. But actually on the main unit itself, it doesn't look too bad. It's not too bad in there. I don't think so much water's got in that side. So what we've done here is we just check the speaker. That's always something that can obviously go on these units. So what I've got at the moment, I've got the K-Moon FY 6900 signal generator across the speaker, and we'll just put a 1 kHz tone on there, and there you can see the speaker is absolutely fine. I did test it with the DVM as well, but it's always worth checking to make sure your speaker actually does work properly with an actual audio signal going through it, and that's why the FY 6900 is very, very useful for doing that. So there is something else that is restricting our audio. Let's see if we can find out what it is. Okay, so it looks pretty manky underneath here. That's where the shield has been, and you can tell it's had water damage because there should just be normal cardboard, and you can see it's all wrinkled where it's been soaked with water. So I think we will give this the benefit of the doubt. I think we can probably, I'm confident we can get this going. There's very likely a dry joint somewhere on the back of there, and there's definite shenanigans afoot here. There, so I do have one of these, as you might know. I've got pretty much most radios here, so I can look at the a nice clean one that works, and we can establish what should be there and what shouldn't be there. So I think what I'll do first though is go and give this a clean with some isopropyl alcohol and a toothbrush. There we go. Look how that's cleaned up. Lovely job. I've just ordered some more isopropyl alcohol because I go through it. It's great stuff for cleaning the boards. That's nicely dried off. So what I'm going to do is just going to very carefully look round that, We're going to use the pine sill soldering iron. If you haven't seen the video I did on this iron, it's a fantastic budget soldering iron. Really is the business. So if you're after a nice little iron, you don't want to pay Weller money, because that's silly money. Go for one of those, they're great. So have a look in the channel for the video I done on the pine sill soldering iron. Fantastic for this CB stuff. Okay, right, let's see if we can find any dry joints and get that receive back into life. As we've heard, it's not the audio IC, I'm pretty sure of that. There's something before that that's causing that issue. It could obviously be the subsystem chip. Perhaps I should get my other radio down. If I've got it, I just had a thought that might have been a customer radio, so I might not have one of these, so we'll find out anyway. I'll just go and have a rummage. And would you look at that, we're alright. We did have one, I thought we did. There we go, look, that's all the accoutrement. We've even got the aerial in there. So we do have one we can have a little look at. So what I should do, because it's a lot easier checking voltages and things. Look at that, it's really nice and clean in there. So we do have this one that we've had on the channel before. I'll whiz the back off that, and then we'll use it as a reference, get some voltages off that. And this is why it's always handy to, if you're in the business of repairs of CBs, to literally have one of everything. I know it's not practical and you end up with a room full of CBs as I've got, but it can save you a lot of time, trust me. Okay, there's my one with the plate still on it, and we can see it's still got the same arrangement with that resistor there. And looking at this one, I did wonder whether that resistor should be there. It does look the same, so I don't think there's anything too untoward there. But that's good though, we've got the back off of this. I'll put this to one side now and we'll just have a little probe around. Okay, well, I haven't got a schematic at the minute. I've just seen if Richard could send me one. But I've got my radio that I know is working here. We've got a signal going into it, and this is the input into the sound IC. And if you just, I've got my external speaker connected up here for a capacitor. There you can hear we switch the RF off, and you can hear the input into it there. So that's all on the other radio. That's all we're getting off that input when we've got a signal coming in. So it's either the crystal filter, it's not getting through that, or it's the squelch circuit or something. Something's causing it to be a problem. But I'll just show you the other one in comparison. So we'll put the tone back on. You can hear it coming out the speaker. It's quite loud. There we go. So we've got that, and I'll show you the other one. Yeah, and here's on the other one. See, we've got no tone. It's on. We've got 100 microvolts coming in, but we've got no tone. That's on the input. So that's what we're looking at. The sound chip is good, but I have a funny feeling it might be the MC355 chip. So I'm going to have to just look into that a bit further. Okay, I printed off the data sheet for the MC3357. And we should be getting the audio output on pin 9 here. We're getting nothing, look. Nothing on pin 9. I'll check on the other set, but my watch has just pinged and Richard's just sent me a schematic diagram, so that'll be useful. I'll go and print that off. And you can hear that on the good one, the signal coming through, and there it is on the pin 9. That is the output of the MC3357. Richard has very, very kindly sent through, this is Richard from UK CB Servicing, he's very, very kindly sent through the service manual for me, so that's going to really help in diagnosing this problem further. So thank you, Richard. Now I'm pretty sure that it's the MC3357 that's at fault, but the nice thing about having a service diagram here is that we can measure the voltages on all of the pins of the IC to see if they tie up with this chart. So I'll just do that now, and I've got a funny feeling that they're not going to. So yeah, apart from the supply voltage, which is correct, it's 6 volts, none of the input voltages tying up with what they should be on that chart on this one. I'll just will check on the working set just to make sure that's correct. Yeah, I'm pretty sure it's the MC3357P that's at fault there. The other radio absolutely is fine. All the voltages tie up on the working radio, but none of the voltages around this IC are adding up. So that's the most vulnerable thing within there. And I think it looks, if you look at the actual top of the IC, just there, it looks like there's been some liquid got onto it, and it maybe have generated a hot spot or something. I haven't got the thermal camera plugged in, but I'm sure it might also be running a bit warm. I can't feel that it is, but yeah, if I've got one of those, I think I might have on another radio. We shall swap it out, take it out, and I'm pretty sure we'll get our receive then. Alright, before I take the IC off, I did notice on the back of the board, you can see this blackening. I've desoldered the contacts there. There's a blackening on the, like the PCB's got hot, and I noticed there's some heavy corrosion on the leg of that transistor. Can you see it just there? So I'm going to take this transistor out and pop it into the tester and see if it's okay, because it is tied into the MC3357, so I don't want to go putting another chip in there and frying it. So let's just see what that transistor does. Let's have a look at the schematic as we've got it. Okay, so that transistor is Q14, and what it's doing is switching pin 13, which is the scan control pin on the MC3357. It's switching that to input 6. I think it's joined through on the MB3713. Now I haven't looked at that IC to see what that's doing, but I'm pretty sure, I don't think that's our problem, but I don't think it's helping. It's very corroded, so let's just get it off and see, and if not, we'll replace it anyway for an equivalent TRC-1004. We'll find out what the equivalent transistor is, and we'll get that out of there. I mean, amazingly, that transistor is still alright, even with its dodgy leg. It's got a HFE of 425, but I'm gonna find an equivalent and replace it with something similar. Right, I've got the old one out. I have got 2 brand new ones here in stock. I must have bought them off of eBay a while ago, so I'll get one of these popped in the radio, and hopefully it'll crackle back into life. Right, there's the new chip in there. Let's turn it on, see what we're doing. And there we go. We got our tones. That was it. I did suspect it would be that. I put a new transistor in there as well. We changed that for a brand new. I had some new stock of 945s anyway, so that's got the correct transistor in, and that is great. So I think we're good. We've got our transmit. We've got our receive now, so that's excellent. It's now Friday night, and I've been on this a little while, so I'll now I know it's all hunky-dory and worth persevering with. We shall give it a bit of a tune-up, but I shall pop downstairs and have a relaxing evening, and then start on this in the morning, so we can report back to Steve and let him know that this is okay. Right, it's the next morning now. I'm going to deal with a little bit of this corrosion here. Just going to lightly sand that off, and then I'll put a little bit of anti-corrosion paint on. We've got a screw there which I think is going to be tough to get out. I'd like to replace that with a new screw if possible, because that's quite corroded, so we'll do that next. Alright, we've replaced the screw for a nice stainless steel one, a cap head there, and I've cleaned all the corrosion off that switch and lubricated the switch with some switch cleaner, so that should be good. The other screws are okay, they're not too bad at all, they can stay as they are. So we'll flip it over and have a little look at the underside. There are some screws with a little bit of corrosion on here, but they're not bad enough to warrant replacing. They're okay. This little pine till soldering iron, even on 12 volts, is still man enough to do that. That's great. Right, now according to the service manual that Richard kindly sent through, the DC power supply can be set at 13.2 volts. So I've done that, and I'm going to actually set the VCO as it explains on here. So if you need to do that yourself, that's how you do it. That's how you set the VCO. You can pause the video there. So I'm going to do the VCO first. As this has been dunked, and I don't know if it's been fiddled with. I'm just going to run that check first, and then we'll just go through the basic alignment of transmit and receive as I normally do. Okay, that's all good. We are doing, I think, about on 13.2 we're doing just shy of 4 watts. 4 watts there. We need to bring it up a little bit, and to do that, T8, T9 and T10, those two there. T8, T9, T10, T11, and then we've got L4 there and L7, and then this is the loading coil for the antenna. So I'll probably plug in my antenna into this and then just check that with the field strength and adjust that with the field strength meter. But then we'll also check the harmonic on that as well with the spectrum analyzer, just to make sure it's minus 80 dB, which is as per the manual here. So let's do that. I'll come back when we're done. Okay, VR4 is your deviation adjustment, which you should be able to see right illuminated in the picture there, that white one there. You can kind of get your adjustment stick in at a bit of an angle. You would have thought they'd have just machined a piece out of this plate, really, wouldn't you? But you can get in there to do it. So I'm going to do that off camera. It's a bit dull, isn't it? We'll get that set up for 2 to 2.5. It says in the book to do it at to 1.75 kilohertz, but we'll do it to 2.5, 2 to 2.5. Right, it's doing 1 microvolt for 12 dB synad, and it sounds a bit strangled, doesn't it? So I think it's been fiddled with. So we're going to adjust the FM detector. We'll just turn let's get that off. We'll just adjust the FM detector on the oscilloscope. Let's fire the scope up, and we'll peak that first with a 100 microvolt signal from the RF signal generator. There we go, and let's adjust the it's the blue trimmer. I'll show you on the PCB in a minute. There we go. We're just adjusting that for peak. That's peak there. And for receive alignment, we've got T2, T3, T4, T5, and T6 is that is the one there for your FM modulation adjustment, which is what we've just done on the scope. Okay, so that's your FM detector. So we're just going to be adjusting T2, T3, T4 and T5 there, and I'll have a listen to it as well, just to make sure we're not strangling it. Okay, so we got it to 0.95 of a microvolt, 0.9 of a microvolt for 12 dB. It doesn't sound that great on the low end, not a lot I can do about that, but it sounds fine as the signal picks up. But on the low end, we'll see how low we can go with it. There we are, down at 0.2. We've just about got it at 0.2, so that's not too shabby really, and it's within spec. Okay, I'll just adjust the squelch. We'll just set it for threshold there. We've got a 1 microvolt signal. There we go. Let's see when that's dropping off. We'll roll it down. And it's not going off. So it's not the best squelch. It's just gone off there, 0.13. So it's quite a wide hysteresis, but it's still not the best squelch. But it's adjusted at the top end as well. And like I say, the radio does sound a little bit strange on the really low end signals. Again, it could be something to do with the fact that this has been dunked. But to be honest, it doesn't. I mean, I'll tell you what I'll do, as we've got it here. Well, let's try it compared to my one, which I know is good. Let's see what that one sounds like. Oh look, my one isn't even receiving that signal at 0.13. So this one's better. So that one is better than mine. I'm just going to wind it up. We're starting to hear it at 0.2. That's 0.4. Let's put mine at 1. See how mine sounds at 1. There's mine at 1. A bit more volume. Sorry, volume. So yeah, that doesn't sound that great at 1 microvolt either. So I just think we're looking at just at the peculiarities of the circuit and how it works. So, but yeah, certainly that one is actually is more sensitive than this one a little bit. But this one's probably slightly cleaner. So there we go. Horses for courses. Well, we'll just give the case a little bit of a clean. Perhaps give the front case a bit of a clean as well. And then we'll reassemble this. Right, there we go. That's cleaned up rather nice, I think. Gave the insides and the outsides of the case a clean there. There's our local repeater, GB3AH, nobody on it as usual. Yeah, so what I think we'll probably do is, as we did with the AM set, is we'll perhaps give Tyler a shout and see if he wants to come and help us play around with
Right, as it's a rescue radio, I thought I'd come out to site, come back out to that location that we used in the GE rescue radio video. If you haven't already seen that, click on the channel, go and have a look at that. We're about 1.5 miles roughly from Milo home location, where Tyler's going to be sat with the Danita 3000. We're just going to do a test between there and here to see how this repaired radio performs, the TRC-1004. And we'll also use the President Randy as well, which we've got in this box. And I've also brought out, like I say, the telescopic antenna that comes bundled with the TRC-1004 in case of such an emergency. Right, so let's get set up. I think we're going to use the antenna on the roof, which we'll see now, as the first antenna, and then we'll swap over to the telescopic antenna after that. So hopefully we should be able to get hold of Tyler in just 1 second.
Right, I believe Tyler is on at the other end. He's just setting himself up ready to record, and we should be good to go. It seems nice and quiet out here RF wise, so that's good. We're kind of in the middle of nowhere where we are at the minute, so let's see how. I think it's going to be a lot better than the AM set. I think we'll find it should be half decent at this end anyway. Right, so let's try for Tyler.
Hi there, Tyler. I wonder if you're hearing me okay. We're about 1.5 miles away.
Half miles away in the car here, and we've got the repaired realistic TRC-1004 from 1981. This is doing a full 4 watts at the moment. I wonder how you're receiving me there on the Danita 3000 today.
I can hear you pretty good.
Oh, he's very clear there, isn't he?
Okay, what I'll do then, I'll just knock it down to 0.4 of a watt. If you can turn the squelch...
Knock it down to 0.4 of a watt. If you can turn the squelch down so you can hear it crackle, because I'm probably going to disappear under the squelch. So if you turn the squelch down now till it's crackling, and then I'll come back.
Right, now this is me on the TRC-1004 on 0.4.
Now this is me on the TRC-1004 on 0.4 of a watt. I wonder what kind of difference that's made, Tyler. You can turn the squelch back up in a second. I'll put it back to 4 watts. So I'm going to go back up to 4 watts now. There we go. We're on full power now. I wonder what difference that's made there.
When you turned it down, I think there was a bit more like static in the background.
Yeah, that's right. That's what it would do there, Tyler.
Tyler, that's absolutely brilliant. Well, you're absolutely end-stop with me here. Absolutely brilliant signal, as I would have expected. So that's great. Okay, you can stop the recording now, and we'll change over to a different radio as a comparison. So if you just stay on the frequency, but stop recording, and now we'll try another radio. Okay?
Okay.
Okay, let's try with the President Randy.
Hi there, Tyler. Now using the President Randy on a full
4 watts there, on full 4 watts. So we're using the same antenna on the roof there. I wonder how that's sounding to you. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
It also sounds pretty good, and I think there might be a bit more static in the background as well, though.
Okay, that's interesting. Yeah, I think on the C's you sound about the same. I think probably the realistic sounds a little bit better on the C. It's got a slightly bigger speaker. Okay, I'm going to change this to low power now, okay? So stand by.
Right, now this is me on low power, Tyler. You might have to bring the squelch down. Can you still hear me okay?
I can hear you okay still.
Oh, okay, that's good then, that's good. So this is low power. This should be
0.4 of a watt as well. I'll turn it back up to high power. There we go, we're back on the full 4 watts now. Full 4 watts on high power there, Roger. I wonder how that's sounding now.
It's still sounding pretty good as well.
okay. Yeah, you're sounding superb as well. So what I'm going to do now, if you can, we can stop recording now, and then I'll put the little telescopic antenna on, and we'll try that with the rescue radio. That's the last test that we'll do then, Roger. Okay.
Okay.
Yeah, not getting any joy on the telescopic antenna. Whether there's a problem with it, I'm not sure, but I can't hear Tyler and he can't hear me. So that might just be down to that telescopic antenna. I think it's more likely that than anything else. But still, really good performance. Really impressed with how this is sounding. And, you know, we'll... yeah, I think that's all we can do, really. We can't... well, obviously we could try the Randy on the other antenna, but I think it's definitely a problem with the antenna. Right, so we're back on the Stereo antenna. We're just going to do one final test with this realistic, just to make sure we're all good. Okay then, Tyler, this is your dad coming back.
Like I say, we've swapped over to the Stereo antenna now on the roof. Definitely an issue with that little mag mount antenna. I'll have a little look at it. It's probably the lead, to be honest. It's a very flimsy lead, and it's probably got broken somehow. But really pleased with how this TRC-1004 has come out. I'd like to thank Richard at UK CB Servicing for supplying the service manual as well, because that really helps with fault finding, and I couldn't find anything online for that. So thank you, Richard, for that. And thank you if you stuck around to the end of the video. And thanks for your help, Tyler, too. It's really great to actually bounce this off of you there back at base. And normally we'll get Mick involved in these. But I figured as we've just done one from this location, it probably made sense to do another rescue radio from this location as well. So hopefully I've rescued another rescue radio with this repair, and I'll put it back around to you to give me the quick brown fox jumped over the lazy dog.
The quick brown fox jumped over the lazy dog.
That's superb. If you have been, thank you ever so much for watching.
If you have been, thank you ever so much for watching, and we'll catch you on the next one. Take care.